Okay, so today we will do some more applications of this Newton's theorem. Okay, just maybe I will show one more sum which can be done easily using Newton's theorem. So let me take a question. So here is the question. If alpha 1, alpha 2, alpha 3, alpha 4 be the roots of this equation, you have to find the values of this and this. Summation alpha 1 square, alpha 2. So this is a symmetric function you should know. Then summation alpha 1 square, alpha 2 square, and summation alpha 1 cube, alpha 2 cube. Now, this kind of symmetric functions of roots can also be computed using Newton's theorem. See, one way we have already studied, but that method was very much complicated. Like what we have done, we will write this one as summation alpha 1 into summation alpha 1, alpha 2, and c, which are not in the product. But for when a polynomial is of degree 3, finding these things are easier, okay, using the simple algebraic formulas. But when the polynomial is of degree 4, writing this and finding this finding this is very difficult. I find it difficult, to be very honest. Now, how will Newton's theorem help us to find this? So let's see. Solution. Okay. What can this be written as? I have to find number one this summation alpha 1 square alpha 2. Now this means what? The square of any root with the product of another root. That means alpha 1 square with alpha 2 plus alpha 1 square with alpha 3 plus alpha 1 square with alpha 4. Right? Plus then alpha 2 square with alpha 1 and so on. Right? So I will write this as, you just write this square of every term. So alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square into alpha 1 plus alpha 2 plus alpha 3 plus alpha 4. I am writing the summation of this into the summation of this. See, which terms are we getting extra? If I multiply this with this one, that is not there, because alpha 1 square will go with another root, will not go with alpha 1 again. So if I multiply this with this, this is a part of this. If I multiply this with this part, which is a part of this, and if I multiply this with this, this is a part of this. Only if I multiply these two terms, I will get alpha 1 cube, which is extra. So minus alpha 1 cube, right? Similarly, if I multiply this with this, I'll get a part of this. But if I multiply this with this, I will get alpha 1 cube, which is not here. That means, sorry, alpha 2 cube, which is not here. That means minus, I can give a bracket, plus alpha 2 cube. And similarly, alpha 3 cube plus alpha 4 cube. Did you get my point? Did you get my point? This one at least. How this can be written as this into this minus this. This is nothing but S2. This is nothing but S1, and this is nothing but S3. The value of this is this, and I can actually compute S1, S2, and S3 and put the values there. So the value of this is S2 into S1 minus S3. Now you can find S2, S1 and S3 and put the values there. You know how to find S1, S2 and S3, right? Maybe I'll find it a bit later, or you can do in the beginning only. So you have to find S2, S1 and S3. So let's find it out. You know S1 plus P1, S1 plus P1 equals to 0. So you can write now, let's do this. This will imply S1 equals to minus P1. We know S2 plus P1 S1 plus 2P2 equals to 0. So S2 from here will be P1 into S1, which is P1 again, so minus P1 square, so that will become P1 square minus 2P2. And what is S3? So S3 plus P1 S2 plus P2 S1, 3, 2, 1, 1, 2, and 4 P3. So that means 3P3 equals to 0. So that will give me S3 equals to, so P1, let me send this that side, no? So minus P1 with S2, which is P1 square minus 2P2. See, when P1, P2, P3 and P4 are numbers, this will be easier to compute. But because I am doing a general question, so it is a bit difficult to find S1, S2, S3 and S4 and so on. Minus P2 S1, minus P2 S1, S1 is minus P1, minus 3P3. What am I getting? You may just compute by yourself, okay? That is easy to compute. Minus P1 cube minus minus plus 2P1 P2 plus P1 P2 minus 3P3. So what is the answer? It is 3P1 P2 minus P1 cube minus 3P3. So I have the values of S1, S2 and S3. You can put it here to find the value of this thing. Understood? So what you do, you put the values of S1, S2 and S3 out here to get your answer to this one. So anyways, when P1, P2, P3, P4 are numbers, this will be easier to compute. Okay? So let's compute number 2. Number 2 was what? It was summation alpha 1 square, alpha 2 square. Okay? So let's write it down. This can be written like this. So this means alpha 1 square with alpha 2 square, alpha 1 square is alpha 3 square, alpha 1 square with alpha 4 square. And let's go to alpha 2, then alpha 2 square with alpha 3 square, because alpha 1 square, alpha 2 square is same as writing alpha 2 square and alpha 1 square. So remember, that will not be repeated. That means, let me write this first. Alpha 1 square plus alpha 2 square plus alpha 3 square plus alpha 4 square into, again same thing, alpha 1 square, this whole square. You can also write whole square here, but I'm just writing this way so that you understand better. Alpha 4 square. Let's see which terms are extra here. So first of all, this is extra because if I multiply alpha 1 square with alpha 1 square, I'll get alpha 1 to the power 4, which is not a part of this. This only contains the square of the first root multiplied with the square of the second root, or different root, not same one. So what I have extra, I'll get this is extra, this is extra, this is extra, this is extra, right? So minus alpha 1 to the power 4 plus alpha 2 to the power 4 plus alpha 3 to the power 4 plus alpha 4 to the power 4. Now one thing you note, this only contains alpha 1 square into alpha 2 square and not contain alpha 2 square into alpha 1 square, because both the terms are actually same. So this summation only contains the minimum number of terms for which this is the symmetric function, right? But when I am multiplying this with this with this, I am getting alpha 1 square into alpha 2 square, and when I am multiplying this with this, I am getting alpha 2 square into alpha 1 square. I am getting the same term twice. Similarly, when I am multiplying alpha 1 square with alpha 3 square, this one, and when I am multiplying alpha 3 square with alpha 1 square, I am getting the same term again. That means I am getting every term twice, so I can write here 2. Understood? Because every term in this summation, in this multiplication is double. So I can write the double of this is actually this, not this one. Understood my point? Why did I write 2 here, right? So, or 2 times summation alpha 1 square, alpha 2 square. So using the standard notation, this is S2. You may write an exam where S2 denote the or SR denote the rth power, sum of the rth power of roots. S2 into S2 is S2 square minus S4. So what will be the answer to number 2? Summation of alpha 1 square, alpha 2 square is nothing but half of S2 square minus S4. Again, you can find the value of S4 and put it out here. So either you do in the beginning, you find the values of S1, S2, S3, S4, and then you just put the values here. And let's go to number 3. First you copy this down and see whether you have any doubts or not. So number 3, what I have is summation alpha 1 cube with alpha 2. This is very easy. So this can be written as alpha 1 cube plus alpha 2 cube plus alpha 3 cube plus alpha to the power 4 3 or alpha 4 cube into alpha 1 plus alpha 2 plus alpha 3 plus alpha 4, right? And let's see which terms are extra here. So minus, when I'm multiplying this with this, I'm getting an extra term, right? This with this is needed, this with this is needed, this with this is needed. So everything else is needed except this 4 terms, alpha 1 to the power 4 plus alpha 2 to the power 4 plus alpha 3 to the power 4 plus alpha 4 to the power 4. What is my final answer? It is S3 S1 minus S4. And you may just find the values of S1, S2, S3, S4 and find this symmetric function of roots. So Newton's theorem is also important or useful to find this kind of symmetric function of roots. Okay, so just take a note by the end of this question that Newton's theorem is also useful. See, it is useful to find sum of the powers of roots. You can also find summation alpha to the power 10. But it is also useful to find this kind of product. It is also useful to find. I should write in a very simple way. Yes. Summation alpha 1 to the power m into alpha 2 to the power p. So this kind of product can also be found using Newton's theorem. This kind of thing can also be found using the Newton's theorem. So either to find this, you can use the relation between roots and coefficients, but I find that difficult for this kind of product. Okay, so you can use Newton's theorem in this way, which I have applied. So this is all about Newton's theorem. You can do many other questions if you want to. Yeah. If you have any confusion, any doubts regarding Newton's theorem or anything, please ask.